frame, so people are predicting this for years. Look, folks are predicting that AI is going to replace developers. I don't see it. It's going to replace developers who don't use AI. But AI itself isn't going to replace developers. But, overall, we're not very good at some of this. So with that said, I'm going to do my best to still predict some things. Because this time feels a little bit different. Like, AI matters not just to us geeking around on this stuff. AI matters to people in the boardroom, people doing senior positions. It's really easy to disrupt anything. Some of you all are building some amazing things. I'll quote myself because I'm extremely arrogant and full of myself. I'm not, I don't think. But I couldn't find a good quote. So I think the future of software is giving you smarter tools to build smarter apps that run on smarter platforms, right? I think we can predict that's the future. You all are going to keep using better and better tools to build more interesting applications, and they're going to run on more interesting platforms. I think we can bet on that. I said that last year at Next. I think that's true. So what are we going to do? So I'm going to focus on 7 things. I'm going to show you a bunch of demos as well. Most of them will work. We'll see. But I want to focus on what 7 things I think represent the future, right? How should we all be thinking about it? I think the first thing is that all of us as software developers, we're going to swing back from so much complexity back to simplicity. What do I mean by that? Not everything needs to be a microservice. It's time to stop with so many microservices. Let's relax. Sometimes it's okay to build a monolith. Monoliths are cool. Build something quick and easy. Stop over-engineering it. I think a lot of us have over-engineered our systems. And so we got to pull that back, right? Instead of using API gateways plus service meshes plus 12 other layers, maybe you don't need all that stuff. Maybe you can do a little simpler. I see a lot of people compressing. You don't need 4 relational databases. Pick 2. It's okay, right? Can we compress the stack a little bit? So I need it. Open source is it's a little weird right now, to be honest with you. You look at everything from Puppet to Terraform to a bunch of projects where they've switched their license. And so all of a sudden it used to be really easy to just pick an open source project and use it however you want. Not anymore. Even WordPress is weird. I don't know what's going on there. So this idea of open source isn't just everybody can use it. Now there's more restrictions. You have to be thoughtful about which open source you use. Same with dependencies. If you program in Java, Node, Go, Ruby, .NET, any of those, JavaScript, you add a bunch of packages, right? You add a package for logging, for talking to databases, for talking to Google Cloud. That's amazing. But that means for every 100 lines of code you write, you're probably importing 1,000 at least. Where's that coming from? Is there any vulnerability in there? When's the last time they updated that? You are pulling in so much code that you haven't written. It's crazy. We all are. It's not you, we all do it. But where are your dependencies coming from? Can you trust that you're pulling them from somewhere that has them safe? You have to think a lot about that now. Open models, LLM frameworks. I mean, I think since I started talking, there's 2 new LLM frameworks. Like, there's a ton of stuff coming out right now. How do you make any choices here in technology? I think you have to be really thoughtful about which open source you're going to bet on. So what are we doing? Google offers assured open source. This is the most popular Python and Java packages. We actually package them up and distribute them from Google free of charge. So you know that we've secured them, we're distributing them, and you can hopefully trust that Google's taking good care to keep them safe. We use a bunch of open interfaces, so at least when you want to bet on open source, use Postgres. You can use that on every cloud. Use Kubernetes. Use OpenTelemetry. Use a bunch of these open interfaces. They work great. Even using LangChain. So if we look at the model garden, this is the way in Vertex where you can use hundreds of Google models, open models. We just added support for DeepSeek, Live Your Life, that's amazing. You want to use all the different ones from Anthropic, Meta, you want to use Llama, that's great. And so certain models, I can just pick a model like, let's not use Gemini, you're going to use that enough today. I could use something like Llama 3.3, and I can pick that model, I can deploy it to Vertex, I can use it on GKE. I'm still using open models. I'm just running them on Google's managed services. So it makes it really, really easy to run any open model you want. But honestly, sometimes we don't list all of the models. There's a lot. But we actually connected directly to Hugging Face, where I can view Hugging Face models, any of them, directly from within Google Cloud, and then pick which one I want to deploy. Maybe I pick the newest ones. I could pick one of these that I like. Here's another DeepSeek one. I can go ahead and immediately pick that and deploy that somewhere. So we have some really tight integration with Hugging Face, and use open LLMs. Awesome. Let's just run it on the best cloud possible. And then for projects like Ray, where you're using open source, look, if I create a brand new GKE cluster, what's great is that there's a checkbox to say install a fairly complicated open source system called Ray. Maybe I just want to make that really easy and check a box. I don't want to install it and maintain it and patch it. I just want Google to do that for me. Check the box, run this, we do it on your behalf, and you're still using the best open source. You're just not responsible for it, which is pretty good. So Hugging Face integration, open models, this sort of thing, it makes your cloud a lot easier to use. More time just shipping prototypes and experimenting with this. So what does this mean? AI-driven prototypes, this is wild. Like, I don't care if you're using everything from Bolt or Cursor or Gemini or any of these things. The fact that I can go from, I have an idea, to running code in a couple of minutes, I'm gonna do it live for you because we'll see if it works. That's amazing, right? So we can start building prototypes of anything, front ends, back ends, services, pretty sophisticated things. Use V0 from Vercel. Like, there's some amazing stuff out there that you can run prototypes so quick. So if you're not doing this already, you're missing out on something pretty awesome. These are all free, many of the things I mentioned. But of course, to do that, you have to think about what is the stack underneath it. If you can generate a prototype really fast, and then it takes you 3 days to deploy it to a VM, I don't think we're doing it right. So how can I also use services like Cloud Run, managed databases, others that work? I don't really like shift left. I came up with the term shift down. And I think this is actually a better idea. It's the idea that you should shift more responsibility down to the platforms you use. Right? Are we making it easier to do the right thing by making the platforms do all the work? So I wrote a blog post a little while ago that was more crude that shifting left is for suckers, shift down instead. I think that's true. I think we should stop asking developers to do everything, and we should be asking our platforms to be smarter. If you look at that, there's an impossible to read diagram down at the bottom, which shows we keep shifting so much to developers to do the work. But what if we just ask the platform to handle more of the security things and the deployment features and things like that? And so what does that mean? Again, I don't think every developer should have to understand every data framework, security framework, AI, ML, architectures, data access, infrastructure as code. I don't believe there are any full stack developers. If you tell me you are, I don't really believe you, because nobody really knows JavaScript and then like top of rack switches in the data set. If you are, you're a unicorn, and I will worship your amazing abilities. But I don't think any of those people exist. So you think more platform engineering, right? Are you doing this sort of platform engineering approach where you bake kind of platform services, self-service ability there? That's really, really powerful. And so you're seeing more and more teams pick up platform engineering as a discipline. That's pretty exciting stuff. To do this, you have to be really good at automation. So if you haven't gotten great yet at deploying fleets of servers and managing them and keeping them consistent, you're gonna have a harder time being good at this, but good teams who run platforms are great at automation. So what are we doing here? I'll show you a few examples. GKE Enterprise is a great way to actually do a bunch of fleet-based management. You hear us refer to fleets. How do I have 5, 50, 500, 5,000 Kubernetes? I can see here that show me the idea of fleets. You'll see it showing me, hey, I've got 2 clusters in this fleet. I can see that I've actually put configurations across all of the clusters in this fleet because I want them all to have, let's say, the same permissions or same namespaces or things like that. That's a really, really powerful way to see if I have 2 clusters, 20, 200. I'm just pointing at a Git repo that has a bunch of configurations in it. This is used standard stuff. I've deployed that to these clusters, and in every single cluster I have, this one is in Mumbai, great. I can see that it has a namespace installed. I don't do any of that. As a dev, I don't want to do any of this. I just want the platform to do this automatically. And every single new server, every cluster I add to this fleet automatically gets all these settings. So just make the platform do this for me instead of that. Same with policy. If you think of security policies, I mean, I'm a developer, I hate security stuff. I run as admin, like I follow terrible practices. So I need platforms to protect me from myself. Like, can the platform have policies in here that are applying constraints to my cluster to make sure that I'm meeting the benchmarks, that I'm applying good pod security policies, and then rejecting workloads that don't do it? So can I put more in my clusters and itself? Let's talk about Cloud Run. Who likes patching operating systems? No, maybe 1 or 2 of you. It's okay. It's not a big deal. I don't like it. It's not very fun. But if I come into that and say, how do I just have my cloud run services automatically maintained by the platform? I can go in here, I can change this setting. Let me go ahead and edit source. What you'll see is this feature here where I can have the runtime. I can say, have Google automatically manage security updates for my runtime. Yes, please. I don't want to do any of that. Have it patch Ubuntu for me underneath. Have it patch the Node runtime, the Go runtime, the Java runtime, whatever. I think that's great. We need platforms to do some of this for us, but I don't think we just ship it over the wall to a bunch of operators and say, party on my application. We should own some of this. So how do we have continuous upkeep of our systems, right? Famous saying in tech is that software has the shelf life of a banana, right? Even if you don't update, something's going rotten in like a week in your software stack, your operating system, your runtime, your app code, your dependencies. So how do we think about continuous upkeep of our software? How do you keep all the supporting stuff up to date? It's great if your code's up to date. How your docs doing? Your documentation up to date? All of your support material? It's hard, super hard stuff. Are we building services then that are somewhat observable and self-healing? Because I don't think any of us want to get paged at 2 in the morning on a Sunday because a service is misbehaving. I just want it to recover from that failure and get back online. So how are we building systems that give us more free time? We help with that with Autopilot. Again, this is the Google managed Kubernetes. You only pay per pod, not per cluster. However much you deploy, you pay for. We manage the upgrades, we manage the security lifecycle, we get paged if something goes wrong with your cluster. CI/CD, use Cloud Build, use GitLab, use whatever, but automate your path to production and just make it easier. So I think more and more I'd love to see developers owning that app, owning the success of that application, not just writing the code and handing it. There's a lot of AI assistants. We'll do a lot of demos here. I'll use whatever time I feel like, so they won't kick me off the stage, I hope. But I want to show you a bunch of what's day in the life of AI really feel like here. So what do I mean by this? First, let's back up. Let's talk about what Google does. Maybe that's a little interesting. How do we even measure developer experience? What AI are we giving Google engineers? And then what are we trying to give to you as well? So Google actually has a whole system for measuring dev experience, which is, it's hard to do sometimes. How do you measure if you have a productive developer? How do you measure if you have a good dev experience? We really look at 3 things. And we do it by first collecting data. So almost every Google engineer uses the same IDE. We have a mono repo for all our code. We have one service for CI/CD. We're very, very specific about our tech stack. So we instrument all of that. And then we also run a quarterly survey of our engineers. We get all kinds of data, but we measure 3 things to know if Google engineers are happy. We measure speed, ease, and quality. We measure speed, so how fast are you getting value? But that means how much time are you spending coding? How long are your review cycles? Is it happening in 10 minutes or 2 weeks? How many pull requests, change lists as we call them, are going through? When we run the survey, how are you feeling about your velocity? Are you going too slow right now? So we measure a lot of speed metrics. All of these are about 12 total metrics, not a lot. So we measure speed. We measure ease. I love this one. How easy have we made it for developers to use the stack? This is great, right? I can go fast, but I'm fighting my system. That is no good. So have we made it easier to onboard? I love that one. That's a huge deal. Like, you're gonna stay in a flow, you're gonna stay in the zone. So that sort of integrated chat's a big, big deal. We fine-tune that with 25 years of Google knowledge, support tickets, change request information, all that stuff. And then we're doing more for planning, for release management, observability. The point here is that good AI for software engineers is not about your coding assistant. I love coding assistants. Most engineers spend maybe 40% of their day coding. The rest of it's everything else. And so if we're only focused on coding, you're missing so much stuff. Now, some of the outcomes from Google so far, as we mentioned, a lot of our code characters now are coming from AI. Our code reviews are being fed by AI as well. A lot of our Google engineers are pretty conservative though. They want this to actually improve their workflow. They don't want to change their whole workflow. I'd like to change their whole workflow. But for the time being, they want this to just make it better. Super, super important. If you don't invest in upskilling here on just AI stuff, you're going to be in worse shape. Our whole team of tech writers, developer relations engineers spent last year getting smart on AI fundamentals, just so we knew where to apply it, how to use it, those sorts of things. So all of your teams, you should be the champion of that with wherever you work, is bringing that base level of AI knowledge. We have different factors we've looked at for trust. If developers don't trust the AI tools, we know you're not going to use them. Like, trust is the factor. And we look at factors like, hey, how good is the response? If you're a junior or senior engineer, there's a bunch of things there. We've actually built a metric that looks at the whole improvement of AI, which is powerful. And look, the Google Cloud stuff's actually being influenced by Google itself. So what do we provide you? What are we giving you right now that you can use end to end to do great AI stuff? First off, some of the natural language stuff, like, I don't know, I'm not great at writing SQL code, I'll happily admit it. What if I could just talk to my data? What if I could just talk natural language? That's a powerful thing. We talked about this. Agents across the entire software development lifecycle, this is where you're going to be a game changer. Being great at using GitHub Copilot, awesome. Being great at Gemini Code Assist, love it. You're going to improve 25% of your day. I want to improve 100% of your day. So you got to look at the whole SDLC, from how I design to how I do prototypes to how I ship and do test and deployment. That's where you win. That's where you do something special. And then actually using AI to build more interesting software. Like, there's so much going on right now. Do you know all the patterns? I don't. But are we all learning about what some of these patterns are for you doing real time with AI and such? And we're doing a ton here. I'm just going to jump into a bunch of demonstrations, if that's cool, of what does AI day in the life look like, and we'll see if this works. Should be the goal of most of this work, right? I don't want you to burn out. I'd like us to all be doing this for 30 years, 40 years. But how do we do that? I think first off, finally, more executive teams actually care about this stuff. For the longest time, if your executive manager or leader said, I know you're doing a good job by your lines of code, you should run away screaming from that manager. That's terrible. Lines of code is an awful measure of success. The best engineers I know have few lines of code and actually remove lines of code because they're cleaning up the code base. So I need good metrics. I need the things I talked about, speed, ease, and quality, and other engineering metrics. But now finally, we're seeing leadership teams realizing that productive developers might be actually one of the most important things for their company, because you all just doing 10% more software engineering a week probably pays their cloud bill for the year. Like, it's an amazing leverage point if engineers actually can do better work. But you're tracking all the right journeys and metrics. Do your teams know what developers do? I think it's really important. If you don't have this now, Google's actually published some awesome stuff. Here's the 30 developer journeys. These are public white papers. Just copy that and say, this is what software engineers do. If we do AI, we should do it here, 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 here. Awesome. You just need to have a common language with your leadership team. Hopefully you walk away with this. Like, take away this point that if you want to be awesome with AI this next year, you can't just do it in coding. Do it in coding, because that's amazing. Don't stop there. Bring it to how you do design and prototype, do it to ops, do it to deployment, do it to all those things. This is how you become different than everybody else, because a lot of people are stopping at coding. And if you want to be exceptional, you're going to do more than that. And we're doing a lot here, as I mentioned, the deep research work. We do work with Dora. This is the DevOps research and assessment work. Understand what high performance teams look like. You can read those papers all the time. Gemini and Google Cloud, use the app, use search. Like, just use these tools. Make AI work for you. You do not work for AI, right? But then you have to be in charge. You have to decide how you're going to use it, how you're going to change your workflows, how you're going to change what you do. That's up to you. So I would rather, again, like I said, I don't think AI replaces developers. I think developers who know AI replace developers who don't. So be on the former group. Be the group who uses these tools better than anybody else. So I think the future of software is this, right? We're going to focus on simplicity. We're going to choose open source really wisely and the right technologies. We're going to experiment very quickly. We're going to shift down more things so the platform does the work. All of us are going to own more of that app life cycle, because I think that's really important. We are going to use the heck out of AI assistants and make it work for us. And then if we do all that, we're going to be wildly more productive than we were before. So.
No. I fly all the way to India, and that's how you respond. Good morning. Good morning. There we go. Thank you. If any of you want to just yell out in the middle of the presentation, that's okay. If you get excited, happy, all that stuff counts. So, Richard said a bunch of things that I agree with. I think they're really interesting. So, I want you to think about shift down, and I'm going to challenge you with something. The next time you have a manager that tells you, oh, we're shifting right, shifting left, shifting anything else, just say, no, we're shifting down. You're laughing, I'm serious. I want you to say it. And then I want you to copy the response, send it to Richard, see how it goes. Because it's a world movement here, right? So we talked a little bit, through Prashant's introduction and Rich's talk, we talked a little bit about data. And so I have a truism that I'd like to say, and again, if you know what the definition of truism is, it's something that's very small that is true that doesn't mean anything. So don't write this down, it's not worth quoting. But the idea here is, can you think of an application, a cloud application, that doesn't center around data? And then you can extend that by saying, can you think of a cloud application that's interesting that doesn't center around data? And the answer is no. So data is at the heart of all of this. And data is at the heart of AI, we know that. Data is at the heart of our applications. But I want to focus on that because I'm actually here just to warm up the stage for Abby when she comes on, because she's a data expert. And she's going to walk us through how we can start using some of this stuff, do some great demos. But to get into that, let's just move forward. So this slide, Abby and I were talking about this yesterday. I love this slide because it kind of goes through the different phases that many developers feel. And I want to start with, how many of you have written at least one line of code this week? Raise your hands. That is excellent, okay? So how many of you started the week with, you either didn't know where you were going to start, you're working on a project that's really hard and complex, you had to do a whole bunch of learning ahead of time, or you don't even know where the resources are to write that line of code? Hopefully that doesn't lead you to number 5, which means you're going to give up on the idea. Because what Richard talked about was, we're going to provide an intelligent platform, an intelligent way to create those applications, an intelligent way to monitor and manage those applications so that you don't give up. And for any of you who have been doing software development for a long time, and yes, you can tell I'm older, I have, one of the things that's really interesting is that giving up is something that a lot of developers get to. They're just like, I don't want to do this idea, I'm going to go do something else. Richard talked about flow state. I'm going to talk about just trying to decrease the context switching. Richard said everybody should be using code assistants today in various places. Question, how many of you use a code assistance tool, whether it's Gemini, whether it's Copilot, whether it's anything else? How many of you use that on a weekly basis? Let's see. Almost everyone. That's great. That's exactly what we want. That's going to make you 30% plus more effective. And that's how we measure our own teams. So I think that's great. So then when you move up inside there, you can, whether you're using VS Code, whether you're using JetBrains, whether you're using workstations or the shell editor, we support 20 different programming languages as we go through this on Google Cloud. Like, that's a very productive place to be. It's also a very comfortable place to be. But let's move up a step. So then you start talking about code assistants, where we can help generate, we can help complete code, we can help debug your code. You saw that as an example. You can improve your code. You can ask it to say, how might I improve this? And I've got a story about that a little bit later. You can talk about security stuff, and Richard showed that as well. And then the large context size really helps. So one of the things, and I'll get to the story of, I'm actually taking a bunch of classes at a US university in AI to learn more about this. I often just throw a whole bunch of code into my assistant and ask it to summarize, because I want to know what it does. And for any of you that have taken over projects in a team for another developer, one of the fastest ways to learn now is let it summarize it for you. And then you can prompt it and query it for, where are the entry points? What are the things I need to worry about? It's a really interesting way of developing. And then the last thing we're going to talk about, and Richard touched on this, but how many of you have heard of Cloud Assist? Wow, we have one in the back, 2 in the back, that's great. So I want you to think about, when we talk about that intelligent platform that Richard mentioned, this is that notion coming to life. So using Gemini to help you with deployment, management, ops, security, all these things, and potentially even, scaling up and scaling down. And we'll talk a little bit about that, but that's a really important facet of this, because I can generate all the code, I can create amazing workloads, but if I don't have help on the deployment side and on the management side, then we're only doing half the job with you. So what we're here to tell you is that Google Cloud is going to provide all of this. And again, as Richard said, you can use your favorite open source components intelligently. You can use other pieces that plug into this intelligently. But the notion is, Google Cloud's going to provide this environment in which you can work. So if we move forward to the app development side, so that was kind of the coding and tools side. So this one we're going to kind of go top down. So the previous one was bottom up, this one's top down. So we want you to believe, and you saw this with Richard's demonstration of AI Studio, we want it to be as simple as get the API key, get the code right. So day 2, the notion of day 2 and beyond, what are we doing to help you run, manage, operate cost effectively the applications that you deploy? So inside Google Cloud, with the capabilities we're providing through AI, we're adding logging, we're adding monitoring, we've got the security command center, Gemini and databases, so we saw that a little bit where you can actually query your data directly. Gemini and BigQuery, Gemini Looker, the notion of being able to lay out your data in really interesting ways and get insight from that. And then the last one, Gemini and Colab. And I'm mentioning this because I have a personal story here. How many of you have played with Colab? Yeah, I would expect a lot of you play. It's a great way to start learning. So I'm going to tell you a story. I mentioned I'm taking some courses in AI, and I said I'm an old Java guy. But the course was all Python. And so the normal way that I would approach this is, okay, I got to learn some Python, I can do that. But interestingly, Gemini sits inside Colab. So I was able to just query Colab with, hey, I would want to do X. And I would usually do it this way in Java. How would I do that in Python? And I was able to come up to speed in a new language, an easy language. It's not a hard language to learn. But even some of the nuances became very evident.
Just when Richard was on the stage, not that I wasn't listening, Richard's day one demos were amazing. So I wanted to break it down step by step. So this is Cloud Assist. So all you have to do is, you have a laptop, you have internet, I'm not saying right now, at home. So you just go to console.cloud.google.com, right? You just open this Gemini AI chat or Gemini icon on top, right next to the search bar, and click that and ask away whatever you want related to technology. So I'm a new developer enthusiast. I do not know coding, but I want to build an app that can take user text and get responses from the latest version of Gemini, the large language model. Now, do not give the code straight away. Tell me the steps to build such an app in Google Cloud from the scratch, like where I should find an IDE, an easiest programming language for a beginner like me. Finally, provide a simple program to accomplish this and test. I do not want to use a Jumpstart solution. I want to do it from the scratch. The reason I know Jumpstart solution is because I tried a couple of other prompt combinations, and it was great that it suggested the Jumpstart solution for me. Of course, I could spin off one and go ahead with it. But the reason is I wanted to learn and understand more all by myself rather than going with a predefined set of solutions, which is a great way to start if you already know what you're doing and what the services are. And even if you don't know, but then I wanted to understand the components, so I explicitly mentioned that I don't want to start off something that is fully baked in. And then I'm asked recommend a coding environment to start typing the code within the platform itself, and I do not want to deploy anywhere for now because I just want to start with the basics. The reason why I'm writing this as a nuanced, like a brand new developer or developer enthusiast is the fact that we probably have, like in the past previous sessions or in some of the workshops that I've encountered, is that we have all sorts of practitioners in the room, not just developers. We have people who are coming from different backgrounds, like people from the fashion industry, people from authoring industry, and people who are actors. We have search of the things that I want to look for, toys-wise. So let's say I want to look for an yellow plush toy. Or just yellow plush toys in general. Search. Right? It could be a text-based search, or I could also upload images and get similarity matching. So this is what we call as a vector search, because it is not just searching by keywords. It is not just searching by it is not just searching by pictures and just looking at comparing images. It is actually doing vector search, which is contextual. Okay, just a second. Let me see if my internet is fine. I'm actually tethering from my phone. I'm just getting a call. Sorry. All right. So this is a vector search result based on text. So similarly, I'm also able to upload an image of. I don't know if I have toy images right now, but just know that I'm also able to upload an image and able to do similarity search as well. So behind the scenes, what is happening is it does vector search through retrieval augmented generation method. And in just a bit, we'll see where we've implemented this RAG, the vector search approach. And on click of search, it just invokes a method and it does vector search.
Finish this up really quickly. So, this is the time. You're here today because you want to learn. And we really appreciate that. We're here to engage with you. I'm going to be walking around. I want to hear about the kind of things that you're building, because really now is the time to kind of transform those ideas that you have into the apps. Those are the apps that are going to run our economy, run our futures. So I want you to think a little bit about, you're going to get credits through these workshops and events. We've got code labs available for you to continue to learn. We've got the Google Cloud and community blogs for you guys to get more information. Abhi talked about Code Vipassana. It's a great way to get hands-on engagement, to kind of practice with these new technologies. We've got the Build and Blog Marathon, something that you can learn about and engage in. And then the Google Developer Program. We've got the largest developer event that we run worldwide in Next coming up in April. We've got I/O events, of which I believe, has it been announced that we're doing one here? Haven't been announced yet? I'm here to tell you there's going to be one here. So we've got a bunch of other things, the DevFest stuff coming up, as well as all the community engagement we do. So today is the first day, Prashant mentioned this is the first stop of a worldwide series of events that we're running to talk to developers about how they can take advantage of all these tools and capabilities. So I want to thank you again for being here. Enjoy the rest of the day, get hands-on, and let us know how it goes. Thank you very much.
Rising while she was showing those demos, I was trying to keep up with what the different things she was talking about. But
so I come to know that every pregnant mother has to go this monthly visit to the hospital. So I asked my sister, and WHO recommending minimum 8 checkup, so that if any complication identified earlier, the mother can be awarded at the delivery time complication. So after reading all this article, I went to my sister and told, these checkups are very mandated, but why you are missing, you are well educated, but why you are missing this checkup? So one fine day, she take me to the checkup along to the hospital and told, in a hospital, almost 80 plus pregnant mothers are there. 50, 60s are sitting in that, and almost 10, 20 people are standing in the queue. So it takes around 5-6 hours to complete the whole checkup cycle. So I went to the doctor to understand why it takes so much time to do this checkup for a pregnant mother. It's a repetitive checkup. So the doctor told, whenever a mother comes to our hospital, first the nurse will give a token number. Using the token number, we call one by one, where the health worker, the nurses, will use multiple devices like blood pressure monitor, like different 5-6 devices they'll use, like and one by one they record all this vital parameter, and again they put it everything in the paper. From the paper, they again digitize it in the software. If the mother carries any external lab test, again they take the lab test, manually again put it on the software. This takes 10 to 15 minutes per woman to do all this work. And after that, they'll go to the doctor, they go and give this booklet, and doctor will spend 3-4 minutes to understand the patient context, and they will start treating them. This is a protocol. It takes around 10-15 minutes per patient. So that means whatever you do in an hour, maximum 10 to 12 patients, you can handle it. So if 50 patients are there in the hospital, naturally they need to wait for 5-6 hours in the hospital. In industry, we automate everything. Every repetitive task, we use tools and automate it. But in a hospital, still it follows a very traditional workflow, paper pen, very traditional workflow. So I went to the doctor, before even my sister come to the hospital, if you get all this data readily available for you, will you make a quick consulting for her? Don't make her to wait for a long time. So doctor told, yes, that is possible. So that time I'm working on a wearable. I quickly build a prototype, a smart device which can collect all the recommended data, and for a 1 month period, whenever she comes to the hospital, this data in real time sync to the doctors, so she can go to the doctor room. There's a summary available for a doctor, like last month this has happened, this is how the BP, everything is varying, and summary is given. Whatever data doctor is giving in a prescription format, my sister can take a photo and it will digitize and put it in the portal. And all the necessary action will be sent to her husband. Example, if my sister is not sleeping well, okay, the application act like a baby and it talk to the father. Mom is not sleeping last 2 days. Might be she is sleeping in a wrong position. Please go and talk to the mom. So like that, the app will interact her, and it say, this is the 8th week of pregnancy. she may have a lot of vomiting sensation, so please and go give us citrus-based fruits. So this kind of recommendation it will give. So it's a prototype. I did for her. She used it throughout pregnancy, and she psychologically felt she really enjoyed the pregnancy because the doctor is there monitoring her regularly, and every actionable item is informed to the husband.